Here's something most people get wrong about AI risk. They think it starts when the model goes live. But by the time an AI system reaches production, many of the most consequential risks have already been baked in the design phase, in the data choices, in the training process. Domain 2 of the AAIR exam, AI Lifecycle Risk Management, challenges you to govern AI at every stage, not just after deployment. In this video, we'll walk through the entire AI lifecycle from design to decommissioning, identify where risk materializes at each stage, and show you what good lifecycle governance actually looks like. Let's get into it. Domain 2 carries 21% of the AAIR exam, smaller than Domain 3, but absolutely foundational. The subtopics are design, development and procurement risk, model training, testing and validation, deployment risk, maintenance, monitoring and decommissioning, and data and asset management. Think of the AI lifecycle like constructing a building. If the architectural plans are flawed, no amount of quality construction fixes the problem. If the foundation materials are contaminated, the building is compromised from day one. And if you never inspect or maintain the structure, it will eventually fail, regardless of how well it was built. Risk professionals must govern AI at every stage, not just at the ribbon-cutting ceremony. The lifecycle approach also prevents a very common failure mode, risk being treated as a one-time checkbox before deployment rather than a continuous discipline. Let's walk through each stage and understand what that looks like in practice. The lifecycle starts at design, and this is where risk professionals have the most leverage because it's far cheaper to address risk here than after deployment. Privacy by design and security by design are not just frameworks. They are commitments to building privacy and security controls into the architecture from day one rather than bolting them on later. One of the most important decisions at the design stage is the build versus buy versus partner choice. If you build in-house, you have full control but full responsibility. If you buy a vendor's model, you inherit their risk alongside their capabilities. If you use an API-based AI service, you're dependent on a third party's reliability, security, and compliance posture. Each option has a distinct risk profile that needs to be assessed and documented. For procurement specifically, the key tool is the model card, a standardized document that describes the model's purpose, training data characteristics, known limitations, and risk profile. Responsible AI procurement means requiring model cards from vendors and evaluating them as part of due diligence. And in agile development environments, risk gates prevent high-risk features from advancing through the pipeline without appropriate review. Design phase governance is your highest leverage intervention point in the entire lifecycle. This is the stage where bias gets baked in or prevented. And the choice largely depends on whether governance controls are in place during training. Training data quality is the single most important determinant of model reliability, fairness, and legal defensibility. If your training data is biased, incomplete, or contaminated, no amount of post-processing will fully correct it. During training, organizations should apply bias testing using metrics like statistical parity, disparate impact analysis, and equal opportunity measures. These aren't advanced statistics. They are structured ways of asking whether the model treats different groups differently. Red teaming is another critical control. Before a model goes live, ethical hackers attempt to manipulate, confuse, or extract sensitive information from it. If they succeed, the vulnerabilities are addressed before they can be exploited in production. And here's a distinction the AAIR exam tests carefully. Validation is not the same as performance testing. A model can perform well on benchmark metrics while still failing at what it was actually supposed to do. Validation confirms that the model does what it claims to do in the real-world contexts where it will be deployed. Think of validation as asking, does this model actually solve the right problem correctly, not just Does it score well on the test set? The moment an AI model moves from testing into production is one of the highest risk transitions in the life cycle. It's where theoretical risk becomes operational reality. Before deployment, a structured risk assessment checklist should be completed. Does the model integrate correctly with existing systems? Are access controls in place? Is there a rollback plan if something goes wrong? Canary deployments and shadow mode are two techniques that reduce production risk. In a canary deployment, the model is released to a small percentage of users first, allowing real-world behavior to be observed before full rollout. Shadow mode runs the AI model in parallel with the existing system without acting on its outputs, giving teams a chance to compare results before going live. Human oversight requirements must be documented and enforced at deployment. For high-risk AI systems, this means defining exactly where a human must review an AI decision before it's acted upon. And pre-deployment sign-off should require formal approval from the risk owner, compliance, and governance stakeholders, not just the technical team. Deployment is the point of no return in many ways. Once a model is live and making decisions, the stakes of a failure increase dramatically. Here's a scenario. Your model was validated, tested, approved, and deployed. 6 months later, the world changes. Customer behavior shifts, new data patterns emerge, and nobody notices the model quietly degrading. That's model drift, and it's one of the most common lifecycle failures organizations experience. Post-deployment monitoring must track accuracy, fairness metrics, and behavioral drift on a continuous basis, not quarterly, not annually, continuously. Version control and change management apply to AI models just as they do to software. Every update to a model, every retraining cycle, every parameter change should go through a documented change process with governance approval. Decommissioning is the part of the life cycle that almost nobody thinks about until something goes wrong. When an AI system is retired, what happens to the model weights, to the training data, to the documentation? Secure disposal procedures must cover all of these. And legacy AI systems deserve special attention. They accumulate technical debt, run on outdated architectures, and carry unreviewed risk. They're the dark corners of the AI portfolio, and risk professionals need to shine a light on them. Let me close Domain 2 with an area that connects directly to real-world risk management practice: AI asset management. Do you know what AI systems your organization actually operates? What datasets they are trained on? What APIs they call? If the answer is not completely, you have an asset management gap. Maintaining a comprehensive AI asset inventory is foundational. Models, datasets, pipelines, APIs, all of it needs to be cataloged. This is your starting point for risk management. You can't assess risk for systems you don't know exist. Data asset classification means tagging assets by sensitivity, regulatory relevance, and business purpose. A training dataset containing personal health information needs far stricter governance than one containing publicly available product reviews. Data lineage and provenance documentation answer two critical questions. Where did this data come from, and how has it been transformed? Without lineage, you can't trace a model problem back to its root cause, and secure disposal must cover both model weights and associated training data. A decommissioned model that still exists somewhere on a server is not decommissioned, it's abandoned. Treat AI assets with the same discipline you apply to any other critical enterprise asset, because that's exactly what they are.